Hi everyone, I'm going to go through the question that's on page 19 of your electricity packet, the combination circuit. Some of you expressed questions on Schoology, so I figured I'd make a quick video to walk you through it. A quick note though, as these get more and more complex, you may need additional papers to draw them out. And they are kind of like puzzles. The more you do, the better you get at what the next step is. So first off, we definitely see where our initial steps are going to be. We're going to identify what things are in series and parallel. We can definitely see that resistors 4 and 5 are in parallel. Resistors 1 and 2 are in series. And then note that combination of 1 and 2 will be in parallel with 3, which we'll get at in a minute. So really what we're trying to do is break everything down into having just one series circuit. So let's just start with 4 and 5 because that's pretty obvious. So 4 is 12 ohms and 5 is 6 ohms. So when we add those together, we do 1/12 plus 1/6. Hit our equals button and then hit our inverse, and that's going to give us a total resistance of 4 ohms. So what we did before a little bit was on that line we could write 4 ohms. So like on this line here, it was a resistor 5/6 of where it gets combined, or sorry, 4, no, wrong line, sorry guys, wrong 12. So 4 and 5 that would act like a 4 ohm resistor. So whether we're going to do it kind of sloppily like I did on my end, this whole thing is 4 ohms. So then let's jump up to resistors 1 and 2. They are in series, so series circuits add simply current-wise. So they're going to combine to make what we can call resistor 1, 2 of 20 ohms. So this whole thing up top of resistors 1 and 2 is going to be 20 ohms. And you can see for the people that are kind of very meticulous, drawing on a separate piece of paper might be a little bit better, breaking this down. Okay, so the next step is, so we have basically right now, let's find a cool color. Let's go blue. We have our resistor 6. We have our combination of 4 and 5. And eventually what we're going to try and do is get like this resistor here being like 1, 2, and 3. We already combined this to 4 and 5. And then this was just simply resistor 6 that we didn't have to do anything. So we need to combine this 20 ohm resistor up top with what 3 is. So resistor 3 is 5. So we're going to combine parallel-wise a 20 ohm and a 5 ohm. So that's going to be 1/20 plus 1/5. Hit the equals button. And that's going to give us our total resistance for that one. So what was that one? Give me 1 second. That was 4. So this big circuit here, or big kind of combination here, is going to be overall 4 ohms. Horrible handwriting. Sorry. So really it's like having a 4 ohm at the top. Here was our other 4 ohm. And then down resistor 6 was 12. So we can get the total, change my color, resistance for our circuit to be 4 plus 4 plus 12, which is our 20 ohms. So you can see we're completing this in the chart, having 6 different resistors. It would have been a little bit difficult to see what to add. But drawing it out in this separate side, it tends to be a little bit easier. So we have our total resistance. We're looking now for our current total, which 120 divided by 20. That's easy, it's 6. So that means everywhere we're going to have 6 amps. So 6 amps here. Actually, let's go red for a reason. 6 amps at this one, 6 amps here, and 6 amps here. So we can fit in this information at resistor 6 because that was the standalone one. So that is going to have 6 amps. Now, how do we do that with the other combos? Since resistors 1, 2, and 3 are all combined, so how do you write that on a line? So this is where drawing it out and compressing down this more complex combination circuit into the series that we have drawn that I just highlighted at the bottom, and then now expanding it back out. So sometimes it's kind of like, where do I go? You have some options. So right now, the easy way to go is to figure out the voltage at resistor 6 because we have 2 parts of Ohm's law. So V equals IR, so 6 times 12. We have our 72 volts there. So that's done. So the next place, we know at resistors 4 and 5, they compress down to, let's go highlighter, this information here. So that total current was 6 amps. So since we kind of wrote it on the line over here, we know the current is going to be 6 amps for that combination. Well, hey, wait a minute. We have the total current and the total resistance for that little combo section. So why not get the total voltage? So 6 times 4, easy, that's 24. And these two, resistor 4 and resistor 5, are in parallel. So the little trick for parallel, the voltage was the same for everywhere. So both resistors 4 and 5 have the same voltage, whether they were combined into the one or individual. So that then unlocked some information. We have the voltage and we have the resistor for each individual one. So we can then go ahead and find the current. So the current for resistor 4, 24 divided by 12. That's easy. That's 2. And then for resistor 5, 24 divided by 6. That's 4. And just double checking that we're doing this all correct. For parallel, current will add. So our 2 here plus our 4 gives us our combo of 6. So then where's the next step? What else did we write on our line? We looked at resistors 1 and 2. Oh, we don't want to go there yet. Sorry. So let's kind of clean up a little bit here. Let's just erase all this stuff. Make it a little bit neater. So we combine these to be 20. Let's get a darker color, sorry. So we combine these to be 20. And then we broke them out this way as this whole thing to be, what was this total resistance? So 20 and R5. Sorry, I forget what it was. was 4. Yeah. So this total thing here was 4 ohms. And again, remember it was 6 amps for this total thing that I have written in purple. So if you have resistance and current, you can find voltage. Where we go from that, we don't know, but let's just start finding stuff. So for resistors 1, 2, and 3, that has a total voltage of 24. Well, then breaking this back down into parallel, so we're thinking, I'm going to write in purple. So it's kind of like we have 2 things that are parallel, right? So we know the total voltage is 24. Well, what's the little trick for voltage? It's the same at each resistor. So that means we have 24 volts here and 24 volts here. Now for the top part, resistors 1 and 2, that's a little bit difficult because it's going to break it back out into series. So we're going to skip that for now. So looking at this resistor, the one at the bottom, resistor 3 was 5 ohms. So if you know the voltage and the resistance, you can find, that's right, current. So for resistor 3, going into the chart again, I'll keep it in purple just to be consistent. It was our 24 volts, our 5 ohms. We can calculate 4.8 amps. And this is bothering me. So we got rid of that. So then the last thing that we need to do is get resistors 1 and 2, what their individual voltages and currents are. So they are in series. So in series circuits, the current is the same. So if we could find one, the other will follow suit. So looking in the chart, we already combined these two right here. We know that their combination is 20 ohms. Well, we also know that their total voltage is going to be 24. So we can find out their total current, right? So keeping in purple, so actually that's fine, you'll get it. So we know that this is 20 here. This is going to be 24 volts for those two. So 24 divided by 20 gives us 1.2. So their total current is 1.2. And then since they are in series, it's the same all throughout for both. And then that just unlocked the last piece. Ohm's law, we do our 1.2 times 5 to get 6, and then our 1.2 times 15 to get our 18. And then we completed our whole chart. So this was a little bit more complex. If you have questions, feel free to send me a Schoology message or sign up for office hours and I can walk you through. Just to finish this, you would do that power check. So find out the power for each one, the voltage times the current. So this column times this column to get our power. And we would get what we see in the answer key. So we add all those up, and they turn out to be 720. And then we double check that our 120 times our 6, that is also 720. So hopefully that helped. If not, let me know. And stay on the lookout for probably in the next week or so. We are going to do a virtual class when we start the next unit, because I know that there's going to be some questions with light. So have a good day.